All right, college algebra students, we're in a new chapter. We're going to learn another very important skill with regard to functions, and then that skill is going to help us understand some new functions pretty soon, exponential and logarithmic. But before we do that, what we need to do is revisit this idea of a composition. Now remember, back in the day, I think it was section 3.4 or something like that, we had this thing that I playfully called function algebra. And what we did is, if I gave you two functions, an f of x and a g of x, we built a new function by adding them, subtracting them, multiplying them, or dividing them. And so that's what's going to happen here as well. A composition is a way to build a new function. But what we do, to put it in kind of layman's terms, to do a composition, we are putting a function into a function. So we're literally using a function as a piece of input. So believe it or not, you guys have actually seen this before. Back in the day, I think I gave you something like f of x equals x squared, and then I asked you guys to find something like f of x plus 2, right? And so essentially what this means is I'm replacing this x with x plus 2, and so when I did that, right, we got x plus 2 squared, and then we would clean it up and whatnot. Well, that's what's happening here. To kind of put it in the language that's going on, g of x is x plus 2. And what this represents notationally is I'm asking you basically to take the function f and put the function g inside of it. So that's literally what that looks like. So the g of x function becomes the input for the f of x function. I'm putting a function inside of a function. And so again, it would literally turn into g of x, whatever that is, and we're squaring it. Of course, we can do it the other way around. I can put f of x into the function g, right? And so in this case, that would be f of x plus 2, whatever that function f of x is. Notationally, what we have is when we have this, notationally we describe it using what's famously known as fog, right? That little circle does not mean multiplication. It means that I'm taking the function g and I'm placing it into the function f. That's basically that. Same thing here. This would be the reverse, g composed with f of x. So I'm taking the function f and I'm putting it inside the function f. So you know I'm dealing with a composition when you see the little circle. I've got a new function, right? It's called f composed with g. I've got a new function. It's called g composed with f. So that's literally what it translates into when we do that. Okay? And in action, this is what it means, right? We're starting with g, putting it inside of f. Here we're starting with f, putting it inside of g. Right, so it's as you'll see in the future, it's kind of like an assembly line. How an assembly line works: somebody has a function, right? They take an x value, and then we take that value and we put it into another value. So it's almost like I have a box, I painted it red, and then I put a black dot on it, right? So it's basically like a sequence of events happening. So I start with an input, I pass it on to f. And then I take that output, pass it on to g, or the other way around. I start with x, start with g, and then I pass that value on to g of x. All right? And so there's composition. Again, the idea is we're building a new function by composing, by putting one function inside of another. And as you will see, we create a whole bunch of new functions. All right, so let's go ahead and see that in action. So my first round of things here is I've got a function that's given by the line 3x minus 4, and I've got another function given by the line 2x plus 5, and I'm first going to find what is f composed with g. Well, in practice, this means we're taking f of g of x. All right, so I'm going to come over here. I'm basically putting the function 2x plus 5, and I'm placing it into the function f. So wherever I see an x, I'm replacing it with whatever the function g is. So we get 3, 2x plus 5 minus 4. And if we clean this up, we get 6x plus 9. Clearly a new function, right? This has a slope of 3. This has a slope of 2. My new function has a slope of 6. Even the intercepts are different, right? This has a y-intercept at 0, -4. This one has one at 0, 5. Our new one has one at 0, 9. And I created that by putting the function g into the function f. What if I turn that around, right? What if I talked about g composed with f? Well, in practice, right, we're starting off with f of x and putting it inside of g. So this would be g of 3x minus 4. So as far as the g function is concerned, there's the input. I'm replacing that x with that whole function. So this becomes 2, 3x minus 4, and then plus 5. And cleaning that up, we get 6x minus 8 plus 5. We get 6x minus 3. So there would be g composed with f. And so we're basically just putting a function inside of a function. This is a new function. It has the same slope, but very different y-intercept. And the other thing that you see right away with that first example is that the order of how you do this is very important. F composed with g is not necessarily the same as g composed with f. So if I change the order, chances are I change the function. So be very careful about your order, who's starting first and going into what function next, right? So very, very important. So one more example. This time f of x is x squared and g of x is 4x minus 5. So let's first find f composed with g. This means we're finding f of g of x, which means I'm taking the function g, which is 4x minus 5, and I'm basically putting it into that function f. So we're replacing that x with 4x minus 5. So this becomes 4x minus 5 squared. Of course, if we clean that up, I think this is a, we got 4x minus 5 times 4x minus 5. We get 16x squared minus 20x plus 25. So 16x squared minus 40x plus 25. So that's f composed g. What if I flipped it around, right? What if I said g composed with f? Well, this time we're starting with f of x and putting it in g. So we're talking of g of x squared. So this is the input for the g function. So we get 4x squared minus 5. So again, you can clearly see that you have to be careful with the order because they are not equal to each other, right? Actually, one's more tougher than the other because of the work that we have to show. But bigger picture, we're just, when we compose functions, we're putting one function inside of another, right? So we're evaluating a function given another function. All right, so there's your introduction. Obviously, we have much more work to do and things to learn, but we'll see that in some new videos coming soon.